Welcome to Computer Forensics. This presentation is going to be an introductory course covering the fundamentals of computer forensics to get the current audience familiarized with the domain and the process of collecting digital evidence and forensic data gathering.
Hi, my name is Natasha, and I will be your virtual instructor for this training video. In this course, I will be introducing you to the science of digital forensics. Please help support us by subscribing to this channel and pressing the like button below. Digital forensics is a branch of forensic science that focuses on identifying, acquiring, processing, analyzing, and reporting on data stored electronically. Electronic evidence is a component of almost all criminal activities, and digital forensic support is crucial for law enforcement investigations. Electronic evidence can be collected from a wide array of sources such as computers, smartphones, tablets, remote storage units, game consoles, and more. The main goal of a digital forensic specialist is to extract data from the electronic evidence, process it into actionable evidence, and present the findings for prosecution. All processes should utilize proper forensic techniques such as hash function signatures of files or storage devices to ensure data integrity of the digital evidence, to keeping track of evidence custody as it changes hands in the chain of command. Those processes are only a few among many other techniques utilized during processing the evidence to ensure that the findings can be replicated with the same results and that the results is admissible in a court of law. There are multiple subcategories and specialties in the field of computer forensics, each requiring a different set of skills spread across the computer science knowledge spectrum. Database forensics is the process of examining, analyzing, and preserving any database artifacts, analyzing activities within the database system, and attempted recovery of any previously deleted data. Email forensics is the process of recovery and analyses of any data contained in emails, such as email digests, email contacts, and schedules. Malware forensics is the process of reverse engineering malicious software such as viruses, Trojan horses, or malware, such as ransomware, in an attempt to identify or analyze any possible malicious activities or payloads delivered by such systems. Knowing the mechanics of the attacking methods mentioned above does not guarantee the recovery of the data after the fact that the files were encrypted or deleted. But understanding those mechanics will be crucial when developing any policies or plans on how to mitigate such incidents. For example, in the case of ransomware, and prior to the attack, the IT team must determine what data should be backed up on regular basis and how frequently it should be backed up. Also, what is the incident response plan in such a case and which team should execute it? If the investigator is lucky enough to have the computer still be turned on upon arrival, the memory forensics specialist will attempt to analyze and recover any data still stored in the random access memory or page files. Mobile forensics is the process of examining mobile phones in an attempt to recover any information from the device, including but not limited to contacts, phone calls, messages, pictures, video files, GPS locations, etc. Network forensics is the process of collecting evidence from a network by monitoring network traffic and analyzing logs from firewalls, switches, routers, or intrusion detection systems. Accounting forensics is usually associated with white-collar crimes and corporations in the form of embezzlement or corporate fraud. Computers and electronic devices are increasingly being used in committing crimes, or in support of crimes prior or through their execution. Computer systems can be used in the process of committing a crime. For example, a computer can be used to hack another target computer system, or it can be used to execute a network attack, such as a distributed denial of service DDoS, among many other forms of attacks. Computers can also be used in support of a crime by storing evidence of any illicit actions. For example, a suspect can create a spreadsheet of any drug deal transactions and probably have a list of potential contacts. In other cases, a criminal suspect can be searching for artifacts like weapons or explosives on the internet, or they can be searching for information on how to commit a crime, for example, how to poison a person or set a building on fire. Such activities can be pulled by extracting the appropriate entries from the current browsing history. Other electronic devices can collaborate the evidence on hand. For example, mobile phones can reveal the suspect's GPS location history, any text messages sent or received, or any phone calls made. So why is digital forensics important? Crime can take many forms or grouped in different categories. There are crimes against people, crimes against property, or financial crimes involving money or credit cards, and those are just a few examples of the many types of crimes an investigator can encounter. A lot of those crimes might be physical in form and don't involve electronic devices, but sometimes the evidence for those crimes can be stored on a digital device, such as surveillance systems, or in the form of GPS data stored on a mobile phone. That said, how can digital forensics help an investigation? Digital forensics can help in crimes that involve data theft and network hacking. Those two types of digital crime go hand in hand because hackers or cyberpunks attack and breach computer systems for multiple reasons, ranging from simple malicious intent, website defacement for political or ideological reasons, industrial espionage, to getting some form of financial gain among many reasons. The forensic investigator's job is to understand how the breach was executed and identify the persons involved in the attack. Some crimes are considered white-collar crimes, and those usually take place in the corporate world in the form of corporate fraud, embezzlement, extortion, or ransomware. And the odds are a lot of the evidence left behind is in the form of digital evidence. Another form of crime is online fraud and identity theft. Those types of crime can take many forms from social engineering to unauthorized computer access or computer breaches, with the intent of gathering enough information about the target to assume their identity or acquire credit cards under their assumed names. Alternatively, criminals can reach out to the target victims via email or phone and try to swindle them into sending funds back to the culprits through bank wires, money transfers, or any other means like gift cards or prepaid credit cards. All the types of crimes we spoke about above have some form of a digital connection to computers, but digital forensics is not limited to those kinds of crimes. Burglaries, assaults, murder, and violent crimes can also leave a footprint in the form of digital evidence. Mobile phones can contain GPS locations, messages, photos, or telephone calls that can link the criminal to the victim, or a location where the crime was committed. The criminal can also leave a digital trail on their computer in the form of documents, pictures, or a search engine lookup in the browser history related to a crime committed. Some examples of browser searches can be related to how drugs are made, how to break into a car, or how to clone a magnetic key. When the artifacts for evidence are collected for further analyses in the form of digital components, like hard drives or USB sticks, the original artifacts must be preserved, and any analyses should be done on a clone of the artifact rather than the original item. In some departments, the original digital artifacts are cloned twice as an extra precaution, and they are stored in a safe place, preferably sealed in an anti-static bag, with a detailed record of the chain of custody. We will speak about the cloning software in the next section, but before we get there, we have to keep the following in mind. When forensic specialists are performing any forensic analyses on a digital media device, they should be able to replicate the same analyses and extract the same forensic results while maintaining the same hash signature values as the original forensic media every single time that analyses is performed. Otherwise, that analyses would not retain its data integrity, and as evidence, it would not be admissible in a court of law. There are many cloning software that can be obtained from the internet, while some are free, others are sold as commercial products. We don't have the space or time to cover all of the cloning software in this training video, but we can highlight a few of them to help you get started. The first application is FTK Imager, which is free, and one of the few software packages that we are going to use to demonstrate some of the principles of forensic investigation. Another cloning utility is Paragon Backup, which has a free edition, but a commercial version of the software is also available, which comes with more features. IOMI Disk Clone, the free edition, is another good cloning software. The publishers also have a commercial advanced imaging tool that can be purchased online. The links where the software can be downloaded are listed below each of the software titles on the screen slide. In the process of a forensic investigation, we deal with many storage device types, ranging from magnetic hard drives, USB sticks, CDs, DVDs, floppy disks, zip drives, to tape backups. And sustaining the data integrity of those media devices is crucial. This is where hashing comes handy. For example, we can create a hash digest for the entire hard drive, or a subfolder on a USB stick, or even an individual hash digest for a specific file or a set of files on that storage media. As mentioned previously, the original storage device should be cloned and preserved. The analyses should be done on the clones of the original media. Hashing will ensure the integrity of the original data image and certifies that the copy of the media remains unchanged and identical to the original device throughout the investigation process. Thank you for being part of this training presentation. Please help support us by subscribing to this channel and pressing the like button below.